Hey, so we are starting chapter 4. Um, and so we are going to start talking more about probability now, where we've been focusing a lot on statistics. So we are going to just start with the basic concepts of probability. So the key concept in this section is that we're presenting 3 approaches to finding the probability of an event. The most important objective for this section is to learn how to interpret probability values. So, like I've said a lot in this course, it's not only about finding the values or doing calculations, but we also really want to focus on understanding what we get and the interpretations. So that's why it's been so important to focus a lot on our vocabulary and our notations so that we know what we're looking at as we move forward. Okay, so events. Events is any collection of results or outcomes of a procedure. So the events are any collection of results, and a simple event is an outcome or an event that cannot be further broken down. So, for instance, if I flip a coin and I said I got heads, there's only one way to get heads. So that's a simple event. If I rolled a die and I said even, well, there's more than one way to get an even number, so that's not a simple event. A sample space for a procedure consists of all the possible simple events. So like rolling a die, the sample space would be the numbers 1, 2, 3, 4, 5, 6. When we're talking about flipping a coin, it'd be heads, tails if we're only flipping one coin. So now, looking at this example here, it says the following display we use B to denote a baby boy, G to denote a baby girl. So if I just have one, if there's one single birth and there's one girl, there's only one way to get a girl. There was one baby, one girl. That's a simple event. Now your sample space, so when I have a baby, I can either have a boy or a girl. Those are my events, my sample space. Now, if there's 3 births and I have one girl, there's multiple ways I could have one girl. So I could have my girl first and then 2 boys. I could have a boy, then a girl and a boy. Or I could have 2 boys, then my girl. So there's 3 different events, 3 different ways that I could get one girl from 3 births. That's not a simple event. There's more than one way. And then the sample space shows all the possibilities for 3 births. So you could have 3 boys. You could have 3 girls. You could have boy, boy, girl, boy, girl, boy. You could have a boy, then 2 girls, girl, then 2 boys, as you can see. So that's the sample space. Those are all the possibilities. So simple events with one result. When we had one birth, one girl, that was a simple event. We just went over that. We went over, so another example is rolling a die. If I say the outcome of getting a 5, well, there's only one 5. So that's a simple event. Again, what I talked about, if I roll the die and I say an even number, that is not a simple event. Just like there's not a simple event when I have 3 births and I say I have one girl. There's multiple ways to get that. So, some notation for probability. The P is probability. Then you're going to have something to denote the events. A lot of times you'll see an B, or C. Also, we might see they'll just write the event in there. So like the probability, and then in parentheses you'll see heads. That means the probability that we flip a coin and get heads. Okay? So those are some notations. So some things about probability. Most of the time we discuss probability from 0 to 1. Sometimes we get in our heads percents from 0 to 100. But truly, when we're talking about probability, we look at the fractional or decimal number. So I said 0 to 1. A probability of 0 means it cannot happen. It's impossible. Probability of 1 means it's absolutely going to happen. 100%. And so the closer it is to 1, the more likely it is to occur. The closer it is to 0, the less likely it is to occur. Then obviously, sometimes we talk about a 50-50 chance. That's right there in the middle. So for any event A, the probability of A is between 0 and 1 inclusive. So notice the way that's notated with the less than or equal to. That's because I'll see if this lets me write on it. Anyway, so that's because it can be 0 and it can be 1. So just a visual way of seeing that. 1 is certain to happen, 0 is impossible, and wherever your probability falls between is whether it's unlikely or likely to occur. So we have some rules for probability. First, we have the relative frequency. So this requires us to conduct or observe a procedure and count the number of times it actually occurs. Back when you were like in elementary school, you probably did things like this. You might have had like a bag of Skittles, and you saw if I choose 10, how many reds did you get? And so you would say, how many reds did you pick out of how many, there were. So what that says is the number of times A occurred divided by the number of times the procedure was repeated. Again, you could do something like flipping a coin. If I flip a coin 100 times and say when I flip the coin I get tails 57 times, then the probability of tails would be 57 over 100. Now, we think about this. Probability of flipping a coin and getting heads. Most of the time we're like, oh, that's a 50-50 chance. Yeah, that is true. But also, it's not going to usually be exact. And we'll talk about in a minute, the more times you do something, the more times it's repeated, the more likely you are to get to the actual probability. All right, so then the second rule is called the classical approach to probability, where it does require equally likely outcomes. So assume that a given procedure has n different simple events, and that each of those simple events has an equal chance of occurring. So if event A can occur in S of these n ways, then S over n. So the number of ways A can occur over the number of different simple events. So for instance, if I was doing a die, and I said, let's see, number of simple events, and I was to say the probability of a 1. Well, how many ones is there? There's 1 out of 6 different simple events. Okay? Then, Rule 3 is subjective probabilities. It's the estimated by using knowledge of relevant circumstances. So normally we don't do this because we like to be able to show how we came up with our numbers. And so the first two rules gives us a way to kind of back up what we're saying. So now, the law of large numbers, this is what I was talking about when I said the more times we do it, the more times I roll the dice or the more times I flip the coin, the more the closer to the actual probability I'm likely to get. Because if I was to flip a coin 5 times, I would get 4 out of the 5 times I get a tails. Well, that's not what we expect. But also, if I was to flip that coin 100 times, I'm more likely to start to get more heads than just, the tails. Okay? Now, complementary event. So the complement of an event is denoted by that event with a bar over it. So the complement of the event is everything that's not the event, like that's not part of that event. So if I was to say the probability of getting a heads, then the complement would be the probability of not getting a heads. So that would include tails. If I said the probability of getting a number greater than 4 on a die, that would include 5 and 6, so that's 2 out of 6. Well, the complement of that would be everything that wasn't 5 and 6. So that would include 4 out of 6. And what you might notice is that an event and its complement equal 1. So rounding off probabilities. When expressing the value of a probability, either give the exact fraction or a decimal or round off final decimal 3 significant digits. I will say a fraction is usually the best option because it's exact. However, it's much easier to read, much easier to understand a decimal. So a fraction is more exact, but when someone is to read it, if it's not a common fraction, it is harder to know, for some people to know what that fraction is closer to. Most of us can look at 2/3 and we know that's about 67%, 0.67. 5/9, that's 0.5 repeating. So, a little over half. But if you change it to a decimal, take it out 3 significant digits. So, a recap, we discussed the rare event rule was in the beginning, probability rules, the law of real numbers, complementary events, and the round off probability. I do want to speak on complementary events one more time because let me see if I'm worried if I hit slideshow it'll stop recording. So what I will say is that the complementary events add up to 1. So if I found the probability of rolling a 1 on a die, that would be 1/6. So the complement would be anything that's not a 1. So that would include 2, 3, 4, 5, 6. That would be 5 out of 6. If I add the probabilities together, it should encompass everything. So that would be 1. Okay, so make sure you have read the first 2 sections of Chapter 4. And I will be we're going to be rolling through chapter 4 so that we can get through it before spring break.